All right, today what we're going to be talking about is similar figures and scale drawings. So yesterday we discussed proportions and how to cross multiply to solve those proportions. Today what we're going to use that skill and connect it to how you would solve for different things in similar figures. But first we're going to discuss what a similar figure is. So a similar figure has the same shape, but not necessarily the same size. All right, this symbol squiggly line means similar to, okay? It's just one little squiggly line. All right, so for example, we could say triangle ABC is similar to triangle XYZ, just like this one. So we have ABC is similar to XYZ because they are the same shape, but they are not necessarily the same size. Now, how do we know that they are similar? Well, number one, all similar figures have the same angle size, okay? Just like this is 53, this is also 53. Just like this is 37, this also has to equal 7. However, the sides do not have to be the same, they just have to be proportional. So for example, to test that, we could do 10 over 15. So I'm matching up AC, which is the side that corresponds to XZ. So 10 over 15 equals, let's do 6 over 9. If I were to multiply both of these, 10 times 9 would be 90. And 15 times 6 would be 90. Because these two are equal, that means this figure is proportional and similar. All right, so we're going to use this idea to solve this problem here. We have these two triangles that are similar. Use a proportion to solve for the missing side. So just like I did in the previous one, I'm going to take my corresponding sides. So I'm going to have 2 over 5 equals 3 over x. I got 2, 5, 3, x. Then I can use cross multiplying to solve this problem. So then I'll get 2x equals 5 times 3, which is 15. Divide both sides by 2. X is going to equal 7 and 1/2. All right. All right. So what can we conclude from this is that similar figures have corresponding angles that are equal, and the lengths of corresponding sides are proportional. All right. These are the two things we need to know. All right, so moving on to the second part of our lesson today, we're going to be discussing the scale drawings. But first of all, we need to talk about a couple vocabulary words. The first one being indirect measurement. Indirect measurement means using similar figures to compute distances that are difficult to measure easily. So for example, using this particular drawing down here, we have a person that is 5 feet tall that casts a shadow of 4 feet. So he's 5 feet tall, he's casting a shadow of 4 feet, is standing next to a tree that casts a shadow of 10 feet. So it's casting the shadow, it's 10 feet. We want to know how tall this tree is. So we can actually use this idea, set up a proportion. So we'll do how tall he is on top, so 5 over his shadow, which is 4. How tall the tree is, well, that's what we're solving for, so we're just going to call that x over our shadow, which is 10. Then I'm going to cross multiply. So I'm going to do 4x equals 5 times 10, which is 50. Divide both sides by 4, which is 12.5. So my tree is 12.5 feet tall. All right. All right. So another example, it says write a proportion to solve this problem. A building that is 70 feet high casts a shadow of 150 feet long. If a nearby flagpole casts a shadow of 60 feet, how tall is the flagpole? Just going to set up the proportion for you, and then I think you guys get the gist of cross multiplying, so I won't solve it. So we have 70 feet over 150 feet. So my height over my shadow. Then I have my height of my flagpole, which I don't know, over my shadow of my flagpole, which is 60. Cross multiply, solve, and you should get your answer. All right, the last thing we're going to be talking about today is how to use scale drawings. Now, a scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. For example, a map. A map would be considered a scale drawing. The map is not actually the correct length from, let's say, Albuquerque to, I don't know, Los Angeles, but it will give you a similar figure or a proportional drawing of what that length would look like. Okay, so for example, my original photo could then be scaled down, or it could be scaled up. So it could be reduced or it could be enlarged. All right, so just like I was saying, a map, we could figure out how many inches it is from, let's say, we have, I can't really read that underneath there, a town to another town, okay? And it will help you figure out how far away those two towns are, okay? All right, that's all I have for you today. Make sure you come to class prepared to discuss scale drawings and similar figures.